We have planned every single detail of the journey to Mars, from the rocket fuel to the food supplies for the crew.
But we often overlook one critical and fundamental element: the mysterious and highly sensitive human brain itself.
How will our deep psychology and delicate biology cope with the extreme, alien environment of the red planet? The biggest, most overlooked challenge for any Martian crew will be the fundamental problem of sleep and our internal clock. On Earth, our bodies operate on a precise 24-hour cycle, known as the circadian rhythm.
This rhythm regulates everything from our hormones and hunger to our mood and overall concentration levels. But Mars operates on a slightly longer cycle, lasting approximately 24 hours and 39 minutes, the Sol.
This difference of just 39 minutes may sound trivial to the average person, but it is actually a colossal problem for our biology.
Our internal body clock, set over millennia of Earth time, simply cannot easily adapt to the longer Martian day. This constant, subtle misalignment between the body and the environment is known as circadian desynchronization. Even a small desynchronization causes chronic fatigue, severe mood swings, and a drastic loss of focus.
This would be catastrophic for astronauts who need razor-sharp concentration for dangerous tasks and critical decision-making. Scientists have already tried to test the Martian time problem here on Earth in controlled labs.
The results were mixed, proving just how stubborn and difficult the human body clock truly is to reset fully.
Some individuals adapted easily to the 24-hour, 39-minute Sol, showing high performance and stability. But for the majority, the constant, minor phase shift quickly led to severe sleep disruption and exhaustion.
This suggests a potential biological requirement for a chronotype matching process to select the right crew.
Only astronauts with highly flexible circadian rhythms could successfully withstand the challenge of Martian time. But the problem extends far beyond the duration of the day itself. The Martian environment brings new challenges.
The first issue is light. On Mars, the light intensity is significantly lower than it is here on Earth. This dim, reddish light is not powerful enough to effectively regulate the production of melatonin, the sleep hormone.
Without strong light signals, the brain struggles to determine when it should naturally wake up and when it should sleep.
The second issue is isolation and monotonous routine on the Martian surface. On Earth, our circadian rhythm is constantly reinforced by social interaction and varied schedules. On Mars, the routine is highly predictable, and the social circle is extremely small and closed off.
This lack of external stimulation can further disrupt the body's natural cycle and internal clock.
The third issue is the psychological toll of long-term isolation in a completely alien, hostile environment.
Chronic stress and anxiety are known to severely interfere with deep, restorative REM sleep cycles. Sleep is when the brain processes memory and emotion. Impaired sleep directly affects mental health and crew cohesion.
So, what are the potential solutions to keep the Martian crew sleeping soundly and fully functional? The first technological solution involves using artificial light systems within the habitats. Habitats must be equipped with specialized blue spectrum lights to mimic Earth's powerful daylight intensity. These lights are essential for suppressing melatonin during the Martian day and signaling wakefulness to the crew. The second solution focuses on pharmacological intervention, carefully managed sleep-regulating drugs. Drugs could be used to precisely adjust the astronauts' sleep cycles by accelerating or delaying their internal clock.
However, reliance on pharmacology carries the risks of side effects, dependency, and long-term health issues. The third, and perhaps most promising, solution lies in advanced wearable technology.
Smart devices can monitor light exposure, track core body temperature, and precisely predict when the astronaut should optimally sleep. These devices provide biofeedback, giving the crew individualized control over their rest and performance levels. But even with all of this technology, the fundamental biological mismatch remains a massive risk.
Some researchers suggest that the only true long-term solution is genetically modifying the astronauts.
This radical idea involves altering the genes responsible for regulating the core circadian clock to perfectly fit the 20. This would create a truly Martian-adapted human, biologically engineered for the red planet's unique environment.
The challenge of Martian sleep is a powerful reminder that space exploration is fundamentally a biological endeavor.
It reveals that the most complex frontier we face is not the void of space, but the human brain itself.
To truly colonize Mars, we must first learn how to perfectly rewire our biological essence. The survival of the first Martian crew may very well depend on successfully negotiating these crucial 39 minutes.
The final frontier begins and ends not on the red planet, but within the mysterious confines of our own minds.
Consider the historical parallel. Early settlers on Earth faced geographical and environmental challenges.
However, none of them ever faced a fundamental, unchangeable shift in the timekeeping of their entire planet. The Martian time shift is a constant, subtle jet lag that can never be fully resolved by simply moving east or west. This is a perpetual state of misalignment, a conflict between Earth-based biology and Martian reality.
Furthermore, scientists are concerned about the long-term effects on the astronauts' bone health.
Poor sleep directly compromises the body's ability to repair microfractures and regenerate bone tissue.
Combined with Mars's low gravity, chronic sleep deprivation could lead to severe, debilitating skeletal issues.
The psychological impact of sleep loss also extends to the entire crew dynamics and group cohesion.
A tired mind is an irritable mind, prone to miscommunication, conflict, and flawed judgment calls.
In a closed habitat where trust is the ultimate currency, sleep disruption becomes an existential threat to the mission. Mission control on Earth must also adapt to the new time schedule, facing a continuous, creeping time difference.
The communications teams must remain flexible, operating on the Martian soul to coordinate vital activities effectively.
This adds another layer of complexity to an already challenging communication delay between Earth and Mars. The future of Martian habitats must incorporate natural elements to trick the brain into a healthy rhythm. Utilizing dynamic lighting that gradually shifts from warm sunrise tones to cool daylight and then to red evening light is crucial.
Incorporating water features, plants, and even simulated nature sounds could psychologically anchor the crew's internal clock.
Ultimately, the question is not about the technological fix, but the adaptability of human nature itself.
Can a species that evolved for 4.5 billion years on one precise time cycle truly transition to another?
The answer will be the ultimate testament to human resilience, or the final, hard biological limit of our race. The challenge of Martian sleep is the quiet, daily test that will determine the very success or failure of all deep space colonization. Will humanity conquer the final frontier? It all comes down to the next 39 minutes every day. This biological hurdle is the hidden key to unlocking the red planet.